10. Today we are going to be multiplying and dividing algebraic fractions. But before we do that, let's quickly review the factorising that we were learning last lesson. So in question 1a, we have two terms that are being subtracted and we have an a squared in there. So this is a difference of two squares. I can square root 36a squared to get 6a, which will go at the start of both of my brackets. And then I square root 25, which gives me 5. In between, one symbol will be a plus and the other will be a minus. B is also a difference of two squares because I have something squared minus something else. So it's going to have the two big brackets again. When I square root x minus 3 squared, I get x minus 3 at the beginning of each bracket. When I square root 11, I have to go to third form. So square root of 11, square root of 11, one is a plus and the other is a minus. In question C, I have 4 terms. So this is factorising in pairs. So I'm going to take the first and second term, and I can see that I have a common factor of 3 and x. So that's going to come out the front, and then that would leave x, take away 2a remaining. Then looking at the third and the fourth term, I can factorise out a negative 7, which will give me a positive x minus 2a. So the brackets should always end up the same, so that the x minus 2a can become a factor out the front, and then the 3x and the minus 7 from the front of those brackets, they go into their own bracket. Part D, this is a difference of two squares again because we have something squared minus something else squared. So two big brackets. When I square root b plus 5 squared, I get b plus 5. When I square root b minus 5 squared, I get b minus 5. In between those, one of them will be a plus and the other one will be a minus. But for the one that's a minus, I need to put brackets around the b plus minus 5, that should be a minus there, so that I can expand that through the bracket. So that will be b plus b in the first bracket makes 2b. 5 minus 5 cancels out, so 2b is all that's left from that first bracket. From the second bracket, I have b plus 5 minus b, and then plus 5 when I times the minus through. Then the b minus b will cancel out, and I will have 5 plus 5, which makes 10. So it's 2b times 10, which is 20b. Okay, so fractions time. Simplifying algebraic fractions by factorising expressions where possible and cancelling out common factors. For multiplication, cancel common factors and then multiply the numerators together and the denominators together. For division, multiply by the reciprocal of the fraction that follows the division sign. And then it becomes a multiplication problem. So question 1, we don't have any multiplications or divisions in here. We want to simplify these fractions by finding common factors. So in A, we can see that we have 20 and 45 as our numbers. Each of those numbers can be divided by 5, which will give a 4 and a 9. I also have an x on the top that can cancel one of the x's on the bottom, so I'll cross the squared out so that there'll still be one left. So once everything is cancelled, all that remains is minus 4 on the top and 9xy on the bottom. In question B, once there are two terms on either the top or the bottom of the fraction, you want to factorise any common factors out first before you try to cancel things off. So on the top of that fraction, I can factorise out a 3, which will leave 1 minus 3x all over 3. That now means that the 3 out the front can cancel the 3 on the bottom, and my answer is 1 minus 3x. For part C, again, I have 2 terms on the top, so I'm going to factorize the top, which will be a 7 and an a that I can bring out the front. That will leave 1 plus 2a inside the bracket. On the bottom, I have 21a. So now cancelling, the a can cancel the a. I can divide by 7. 21 divided by 7 is a 3. So my final answer is 1 plus 2a on the top and a 3 on the bottom. Okay, moving on to some slightly harder ones. Question 2, we are starting by multiplying some fractions together. So I cannot cancel this x with this x while there is an addition in there. So delete that because we can't do that type of cancelling. That doesn't work. But I can cancel the 10 with the 2. So dividing by 2, I would get a 5 here, which will cancel that 2 off or down to a 1. And then I multiply the numerators together, which would just be x plus 4, because x plus 4 times 1 is just x plus 4. And on the bottom, 5 times x is 5x. And that is it. In B, I can see on the top of that first fraction that x squared minus 4 is a difference of 2 squares. So I can factorize that by going x minus 2, x plus 2. The bottom, leave it the same, x minus 2, then times x over, and the bottom of that second fraction, I can factorize out a 3, which will give x plus 2 in the brackets. So by factorizing, I can now see some more things to cancel off. The x plus 2 on the top can cancel that x plus 2 on the bottom. The x minus 2 on the top can cancel the x minus 2 on the bottom. So that the only thing that is left is an x on the top and a 3 on the bottom. Okay, in questions C and D, we're going to start dividing. So you never actually divide fractions, you turn them into timeses by leaving the first fraction and flipping the second fraction. So the first fraction, though, I can factorize the top to bring a 2 out. So 2 bracket x minus 2 over 3. Change the divide into a times and turn the fraction upside down. The x minus 2 will cancel the x minus 2. The 3 and the 6 can cancel to be a 1 and a 2. Multiplying the top together, 2 times 2 is 4, and on the bottom we would have 1, but 4 over 1 is just equal to 4, so we're going to leave it like that. In part D, we have 2x minus 1 over x. The divide, I'm going to turn into a times and turn the fraction upside down. And then I have another divide, which I'm going to turn into a times and turn the fraction upside down. Now I can cancel anywhere top and bottom. So the 2x minus 1 can cancel that 2x minus 1. Then on the top I have 2 times 2, which is 4, and on the bottom x times 1 is x. All right, question 3, simplifying some more. This is already factorized, so I have an x minus 3 on the bottom, just one of them, and I could cancel off one of the ones on the top, so we'll cross the squared off so that there's still one left. The 4 and the 2, I can divide by 2 to get a 1 and a 2. So what is left is a 2 and an x minus 3 on the top, and it would be all over 1, but we don't need to write a denominator of 1 if that's all there is. And part B, leaving the first fraction, I have x take away 18 over 3x minus 1. The divide I want to turn into a times, and I have 7 minus 21x over 2x minus 36. Okay, now at the moment it looks like there's nothing that I can cancel. However, what I'm going to do is factorize the second fraction. So 18 minus x over 3x minus 1. If I factorize a negative 7 out of the top of that second fraction, I would have a negative 1 plus 3x. And on the bottom, if I factorize out a negative 2, I would have negative x plus 18. Now the order is different, but 18 take away x is the same as negative x plus 18. And 3x minus 1 is the same as minus 1 plus 3x, just different order. So I have minus 7 over 2. Even the minuses can cancel out. So I simply have 7 over 2 as my final answer. Okay, time for you to practice in exercise 5C.